Okay, I think we're good here. Okay, welcome in everybody. I think everything is working properly, looks like. Okay, so I will wait a little bit to take roll. Still have to do that. Census was this weekend, so I dropped a few people from various classes. I think the people who got dropped in this class, it all came down to people who had never even attended. So there wasn't like any of those close situations. So if you're nervous that maybe you got dropped, you can always just check in your schedule. But I think in this class, everyone who I had dropped, it just matched up. They'd done no work and not attended class at all. So it was easy drops. There's no like close ones or anything where I had to like make a decision or something. So yeah. So, but I still need to take roll. So let's see. I should be able to do it from the participants. But if you're only on the YouTube stream, then if you could at some point just put your first name and then the last letter of your first name, and then I can take roll here in a little bit. But I don't want to do it yet because I know more people will be coming in. Okay. Right. Everyone good? Okay, so right. So right, so we're getting into the new material that is due coming up. And then so I kind of looked over the grades and it looks like people are kind of working about in line with the due dates. So you've got, we've got a little bit of homework that's due today. And it looks like most people have a pretty good jump on the homework that's due today. Some people really haven't done some of the work, right? So those people you're going to be busy before midnight, or you're going to end up with the last, you end up with the half credit, right? Doing it late. But you don't want to do that. That's kind of a bad habit to get into. Hold on one second. My dog's going nuts. I'll be right back. All right, sorry about that. My dog, we have a 7-month-old puppy, and he just sort of went berserk there. He's just barking at the neighbor's cat, but he kind of went wild. Where was I? Oh, right. So looking over the homework, people have kind of done, many of you are sort of what I would call caught up, or it looks like you will be probably by the end of the day, where you have the homework that's due today completed. Remember, you can work on homework later, but you're only getting 50% credit at that point. So that's not great, right? So we're entering the part where I know I've talked a little bit about factoring, but I think we'll spend some more time on it. We're kind of here in the factoring and then rational expressions, rational equations part. So I would do them in this order. Because of the order in which I created the assignments, because I was following the order that's in the course outline, but it's the order that's in the course outline is a little weird because you need factoring in order to do the rational equations and rational expression stuff. So even though it might be showing you this order on the Delta Math, I would say do the factoring sections first. And then once you've done those, go back and do the rational expressions and rational equations part. So don't necessarily follow the ordering that's in, excuse me, the ordering that's in Delta Math. I would do the order that's on let's see, I got all these open tabs I don't need open. I would do this ordering right here where you do the factoring homeworks first, then rational expressions, then rational equations. So my goal is today is to talk about the factoring sessions. Uh-oh, did the stream freeze? Or is it just mine? Oh no, it looks like just my computer froze or something. So what I would recommend is doing the factoring sections, then do rational expressions, then rational equations. I'm going to talk about factoring today, and then my goal is to talk about rational expressions and rational equations next time. And then that homework will be due shortly thereafter, and then we'll sort of go from there, and we'll start the next chapter of systems of equations. But that's a little ways off. In fact, I think we'll be back in the classroom before we start systems of equations, and we'll be going pretty good. I do want to point out that the school has finally released the final exam schedule. So if you're on the main Ventura College webpage and you go up to where it says Academic Calendar and you click it and you scroll down, couple things. One, be aware because, this is the, no, I'm wrong. This is my online class. I was thinking this was the Zoom class, or I mean the on-ground class, but this is the Zoom class. So we won't be meeting in the classroom anyways. Some of you might have other classes where you're going to have to end up on ground, but I forgot this is the one. I have two sections of this class. One is fully online and then the other one meets together. So I just kind of mixed up which one was which. But as far as final exams, you can see if you go down here, there's the instructional calendar, which I always recommend students read and be aware of. And then there's the spring 2022 final exam schedule. So if you click that, it gives you some information, which is this is school-wide, and your teachers are not supposed to deviate from this. We can teachers do stuff sometimes, and then like no one reports them, so they get away with stuff. But sometimes people do things they're not supposed to do. So you can't change the time of a final exam. Like I can't just tell you all like, instead we're going to do it at this different time. I would get in trouble for that because then people would say, well, I signed up for this class that at a certain final time. Why would it get moved to when I have to work or something, right? So we have to have them at the time that the school dictates. Let's see, there's a question. Okay, yeah, so there's a question about tests, which I'll talk about in a minute. There will not be multiple choice. Multiple choice tests in mathematics are frowned upon. They're not really effective, and they're not really good at reflecting grades. So there will not be multiple choice. Okay, so the way you read the final exam schedule is you find the start time for your class. So we are, a Monday class at 1 p.m.? Is that right? I'm not seeing, let's see, Monday or Monday, Tuesday at 1 p.m. That's us, right? 1 o'clock on Mondays. Yep. Okay, so you can kind of see I've got it highlighted there. So this tells you the day and time of your final exam. So the column is the day. So your final exam will be Monday, May 16th, and the time will be 12:30 to 2:30. Right there, you can see that. So I'll actually have the exam open earlier, so you could complete it earlier if you wanted to, but I can't make it due later. I have to cut it off at the time given here. So that's kind of their rule. We have to make the final exam time meaningful because the state is paying us to meet at that time. So I know you may have teachers that are like, oh, we're just going to have a pizza party on the last day. We're actually not supposed to do that because the state's paying us to meet with you for actual school reasons, not for pizza parties and stuff. So I know some teachers do that, but they're not really supposed to do that. So 12:30 to 2:30, I will set it automatically when I set the final exam. It will, the cutoff for when you can work on it is 2:30 p.m. on May 16th. I can't take it a minute later. They're very strict about these times because what they don't want is like, sometimes it seems like, well, can't you be flexible and let this person take it late? But then it opens us up for complaints where like maybe one student or a group of students are like, well, he made us take it at the given time, but then he let those other people over there finish it late. and then you have all sorts of like problems that are unprofessional and stuff like that. So the school's pretty strict about final exams, and a part of my contracted work is to stick to those hours. So what that means is I will open up the exam early, but the absolute latest is 2:30 p.m. on Monday. In fact, at 2:30 p.m., I'll probably start crunching numbers to submit to the your grade. So either later that day or the morning, I'll be submitting grades. So basically know when that is. Make sure that you do whatever you have to do, because it's a kind of a weird time. We don't usually meet from 12:30 to 2:30. We meet in a different way. So just kind of be aware of that time. Make sure you don't have to be at work or some other obligation, and that you can finish up your test. Or like I say, since it's an online test, I let you do it earlier. But I'll have to kind of see how I want to do this. There may be a written portion of the test where you have to write stuff out and turn it in that way. We'll kind of see how the semester goes. So I'm not 100% sure, this being my first time teaching this class, how I want the final to be structured exactly, but you will be able to turn it in ahead of time. Please also note that if for some reason you have some kind of, like I say, since you can do it early, there shouldn't really be any kind of conflict. But just be aware, we can't make exceptions for stuff that's not done on time. They say students may request a petition from the division office if you want to request an early or late exam, right? So approved petitions must be submitted and filed in the office of the division dean prior to the exam date, which means you need to get the signature of me and the dean before the exam. So if you just show up late for the day of the exam, then you didn't fill out the paperwork ahead of time, then you're out of luck. Now, if it's an extreme situation where like you were in an accident and got rushed to the hospital and there's medical documentation, then we can probably work something out, right? But it's usually something like, oh, my alarm didn't wake me up, or my car ran out of gas, or something like that. For that, we can't really make exceptions, right? We can't really do that. The only two times I've had exceptions granted were both times I think it was women giving birth during the final exam, and so that one's pretty easy to approve, right? Okay, what are you going to do? You're giving birth. You can't be at the final exam, and we approve it. But if it's for like normal day-to-day stuff, my ride bailed on me, or and you're not even going to be coming to campus in this case, but you get what I'm saying. If it's small things like, oh, my computer froze or something like that, I specifically give you time early to finish the test. So if you're waiting till the last minute and then the power goes out or something, then it's not good, right? So make sure that you're setting yourself up for that. And I'm just showing you this so you know the school takes it seriously. About a lot of times it's people wanting to go on vacations. Can I take the final exam early because I want to go on vacation? No, the school wants people taking the final when they're supposed to take the final, if we can help it. Although, like I say, I will make it available to you early if need be. But the due date is at that final. So, I know I'm repeating myself, but a lot of times students wait till that last minute, and I just can't tell you enough. Waiting till the last minute as a student is as a path to failure. It's not a good way to do things. Even if you get by, your work is not going to be very quality work. So just kind of keep that in mind. But you can look up that final exam schedule for all your classes. These are for all classes, not just math classes, and you can figure out when all that stuff is. Okay? And then as we progress through the semester, we'll sort of see what I want to do for exams. Usually what happens when I give an exam is you have like a practice exam. You have some idea of what the problems are going to look like. Not necessarily the exact problems, but you'll kind of have a sense of how the test is going to go. And then we'll kind of see from there. Okay, I'm in the process of setting up the second half of the course right now. Everything I think will be largely good to go soon. I may even get most of it done this week. I got everything sort of squared away, and then it looks like it'll be pretty seamless by the time we get to that second portion of the course. The homework and everything will be all ready to go and set up for you. Okay. So with that said, that should take care of any questions. So if there's no questions, we're going to jump into factoring. So what exactly is factoring? I know I talked about this real briefly a couple weeks ago, but I think we really need a good foundation on factoring, and it's going to help us get those next two sections done. So factoring you can kind of think of as the reverse operation of multiplying, right? And if you think about it, you did this thing with numbers back in pre-algebra. So let's say you take the number, let's just take a number like 22. Okay, so we've got the number 22. And you might remember doing factor trees in pre-algebra. So you just keep breaking the thing down. You draw these little branches coming off. And you'd break it down into smaller and smaller prime numbers that make up that number. So there's different, you're like your factor tree can look different than the person next to you, but the answer that you come up with in the end should be the same. So anyone who is factoring 22 down into its prime components should get 2 times 11. That is the only way that you can break down the number 22 into primes, is the number 2 times the number 11. So then we would say, okay, 22 is equal to 2 times 11. Right? That's what we usually call that prime factorization when we're doing it with numbers, but it's really factoring. You're breaking it down into its component factors. Now, you know, some numbers have different ways that you can break them down, like 20, you can break down as 4 times 5, or you can break 20 down as 2 times 10, or you can break 20 down as 20 times 1. You go, well, that's 3 different ways. I thought you just said everyone should get the same answer. Right, but that was not breaking it down into primes. That was breaking it down into components. If you continue to break it down all the way into primes, whether you broke it down as 4 times 5 or 10 times 2, you're still in the end going to end up with the way you multiply to 20 is 2 times 2 times 5. That's the prime breakdown for the number 20. So 20 equals 2 times 2 times 5. Okay, so that's how you break that down. Well, we do a similar thing with polynomials, where we want to break them down into their basic fundamental components. And it's good to ask the question, why? Why are we doing this? Like when we do algebra, we take an entire chapter on factoring. And I know that a lot of students, when we get to the end, you know, they're like, why did we do all this? So it's, you know, I always try to explain this is what's happening when we factoring and why this is such a big, important deal that we, you know, why are we always telling you to do more factoring? So here's kind of the idea. Let's take a little bit of a jump here. And let's take a polynomial multiplication problem, right? So let's say x plus 2 times x plus 3. We'll just start off simple. So remember what the rule for multiplying polynomials is: you take every term in the first polynomial and you multiply it by every term in the second polynomial, and then you add them up. Or you could just combine them using the operations that you see. Well, if we take every term in this first polynomial here and multiply it by every term in the second one, that's 4 operations that we have to do. So you might remember this one. This is the one we call FOIL. So it's first, outer, inner, last. All FOIL is a way of helping you remember the ordering of your multiplications so you don't forget one. There's 4 of them, right? So what do we do when we do this multiplication here? Well, I do my first, so that's the first term in each polynomial. That's x times x, which is x squared. And then, so FOIL is first, outer, inner, last. So outer would be the x times the 3. So that gives me plus 3x. Now I do the inner, which is 2 times x. So that's plus 2x. And then I do the last, which is 2 times 3, which is plus 6. So if we simplify all that, how do we simplify that? Remember, when we simplify, that's generally, like, simplify can mean a lot of things, but when we're simplifying this, what we're really doing is combining like terms. So remember, like terms have the exact same variable component. So we have a term in here that has an x squared, and it's the only one like it. We have two terms that have an x variable, and then one term, the 6, that has no variable at all. So we have 3 different types of terms. One with an x squared, 2 with an x, and then 1 that's just a constant, okay? So we're going to combine the ones that are combinable, which is the 2x and the 3x. So this becomes x squared plus 5x plus 6. And some people kind of forget, wait, 2x plus 3x is 5x? Yeah, right. Remember, when you're adding, all you're doing is counting. So if you have 3 apples plus 2 apples, then you have 5 apples, right? The apples part didn't change. Sometimes people go, well, don't I have apples squared? Like, that doesn't sound right. You're counting apples, right? It's the same reason that if we add an x term to an x term, then we don't get an x squared term, right? Because you're adding. If you multiply an x term by an x term, you get an x squared. But when we're adding, you're counting things. It's like if I have 3 apples in my left hand and 2 apples in my right hand, I have 5 apples altogether. It's just 5 of whatever I have. So it's the same with x's. If I have 3 x's over here and 2 x's over here, then I have 5 x's altogether, right? That's all we're really doing. Okay. Yep. Thanks for letting me know. Okay. So x squared plus 5x plus 6. So notice there's 2 different ways of writing this polynomial. There's the first line and there's the third line. Okay. So the first line, notice that it's written as a product. It's a binomial times a binomial. But notice in the third line, it's not a product, it's a sum. We're writing things as a sum. X squared plus 5x plus 6. Okay, so we can write this polynomial as a sum, or we can write it as a product. Most of the time we want to write it as a product. Well, I don't know if I'd say most of the time. A lot of the time, yeah, probably most of the time, we want to write it as a product. So it's a little more straightforward to take the product version and write it as a sum. You just do your multiplication. You just go through and do FOIL or whatever the appropriate multiplication is for the particular polynomials that you have in front of you. Going backwards, when you start with a sum polynomial and you want to write it as a product, so you're going from line 3 up to line 1, that is what we call factoring. And you can see it's kind of like what we did up here. We took these numbers and we broke them down into their prime components. 22 is 2 times 11. That's what we did here. We took x squared plus 5x plus 6 and we broke it down into its prime components, x plus 2 and x plus 3. So we've written it as a product of its factors. That's called factoring. Now, factoring is trickier. Like, if you were going to write like, it's not just trickier in the sense that, like, people find it a little more confusing. It's actually, like, objectively more confusing. Like, if you assigned 2 programmers, you said, okay, I want you to figure out how to multiply polynomials together. And then you gave the other programmer the job of, I want you to figure out how to factor polynomials, write a program to factor polynomials. The person who has to write the program to multiply polynomials together will be done in like a few minutes, 10 minutes maybe. Like, it's very, very straightforward because it's just following an algorithm. You just say, take every term over here, multiply it by every term over here, add everything up and combine like terms. It's literally just following an algorithm, okay? The other way around, factoring is harder because it's not always obvious how to break things down into its component pieces. This actually affects your life every day, and people go, oh, that doesn't seem like factoring is important. Many types of encryption rely on factoring, and factoring being very hard to do. So for instance, like you're the browser, where your browser's safe, and when you put your credit card information in your browser to buy something on Amazon or whatever, you don't have to worry that someone is stealing your credit card info because there's encryption that's keeping the whole thing secure, and it's based on this, that factoring is really hard to do. So that's basically how the two ends of the computer communicate. They each know one of the prime numbers, or if it's polynomials, then factors. And if you know one side, then you can figure out what the other side's piece is pretty easily. But if you're a person in the middle trying to do what they call a man in the middle attack, you don't know either side, you're not going to be able to get these really, really large numbers and polynomials factored. Basically, it helps keep you safe. So so you should just understand from the beginning, factoring takes some work to get the hang of, because even though we don't deal with the type of problems that work in the browser. Those are huge polynomials, huge numbers that they use for that kind of encryption. We're doing more basic ones. But the takeaway is that factoring is significantly more challenging than multiplication is. Multiplication, you almost like turn your brain off. You just go, okay, everything here, multiply everything by over here, add them together, and you're good. Notice here, if we were going to work backwards, like notice that we have a 2 and a 3 popping up here. Well, there's no 2 or 3 in our final answer. It's a 6, and there's a 5. Where did the 5 and 6 come from? And you're going to have to sort of look for these clues in the polynomial and be able to work backwards. You're kind of reverse engineering multiplication. You're trying to work backwards through it. So it takes a little bit of work to do. Okay, with that said, the first type of factoring that we need to do is called greatest common factor. And the videos are really good. The videos from Delta Math are good. I'm not like trying to build up the videos that I made, but like the videos that go along with the homework problems, very helpful. Watch those and learn what they're doing. I also think the videos that I give in the that I posted in there, I know there's a bunch of them because there's a whole bunch of factoring that ends up coming up throughout the course. But those short videos are helpful as well. Okay, it's greatest common factor. Hold on, let me close the blinds here. Right, greatest common factor. So this is your most basic type of factoring, is that you're going to see if there's anything that's shared by your entire polynomial that you can factor out. So for instance, 4x squared, let's make it cubed. 4x cubed minus 8x squared plus 12x. So remember, the whole goal of factoring is we want to be able to write this as a product. And looking at it, nothing up there is written as a product. Okay, it's written as like a plus minus there. The glare on me was bad. Was it? On the wall maybe. Was it not doing a good job? Okay, so you look at this. Break these problems down into individual pieces. One thing I see people doing is that they look at a math problem and they try to do the entire thing in their head all at once. Let me tell you, that's not the way to do it. Okay. A couple of things that I try to push my students to do, and when they get it and they do it, they find the problems to be much easier. But before this, if you fight me or you're not really sure what I'm talking about, then you can find the problems more challenging. One is to write a lot of stuff down, like write things down. I see students kind of staring at the ceiling and they're like trying to visualize how the problem is going to work out. Don't do that. Right? That takes forever and it doesn't generally work. So don't try to do the problem in your head. Write it down on a piece of paper. It can be on a piece of scratch paper, and if it looks messy, just throw it away when you're done with the assignment. It doesn't matter. You don't have to show it to anybody. But writing it down is way, way better than trying to do stuff in your head, right? And I think there's kind of there's like, I don't know if laziness is the right word, but there's a tendency to try to be, I'll be generous and say people are trying to be efficient and trying to not write as much stuff while they're working through the problem. But it's, it's the whole go slow to go fast mentality, which is the more you're writing down, it may seem like it's taking you extra seconds to write it down, but you're going to make less mistakes. Mistakes take a lot of time to fix. And also, you're probably going to get to the answer faster if you're writing the stuff down while you're doing it. So please have scratch paper. Please write things down. You will get to the answer quicker, and you will make less mistakes along the way. Okay? The other thing to do is to break problems down into individual pieces. I see students that look at a problem, and they try to do it start to finish in their head all at once. And it's like, that's not going to happen, right? Like, you're not going to be able to do all that in your head. No wonder you're not progressing with this problem. So break it down. So like in this one, our terms really have two parts. There's the coefficient part, and then there's the variable part. And when you're good at these kind of problems, when you have a lot of experience, sure, you can do 2 or 3 things at once if you're really good at it. But when you're first learning it and you're struggling, just break it down into the smallest pieces that you can come up with. So when I look at this, I go, okay, so there's the coefficients of 4, 8, and 12. Okay. Is there a number that divides 4, 8, and 12 evenly bigger than 1? Yeah, 2 divides all those numbers. But we can do even better. 4 divides all those numbers. Okay, so for the number part, it looks like 4 is the number that I can pull out. Okay, good. Right? Notice we haven't even talked about variables yet, and I already know I should be factoring a 4 out. Okay. Now I look at the variables. Okay, I have an x cubed, an x squared, and an x. What is the biggest power of x that I can pull out from all 3 of those terms? Well, it's x because we can't pull out an x squared because the third term doesn't have an x squared, right? So I find this, books oftentimes point this out, but I actually find it confuses students a little bit, but I'll say it. When it comes to the variable, it's the biggest exponent that occurs in all 3 terms. And you might go, wait, this one doesn't even have an exponent. Yeah, technically it's x to the 1. So what's the highest exponent that occurs on those x's in each term? Well, 1. They each have an x to the 1, but they don't all have an x to the 2. Okay, it looks like it's x. So, in other words, we're going to factor out a 4x from each term. And what this really means is we're going to divide a 4x out of each of these. Like, remember the distributive property where you go through and you multiply into each term? Factoring, you're dividing out from each term. So let's see, 4x cubed divided by 4x would leave me with x squared. All right, so what's negative 8x squared divided by 4x? It's going to be negative 2x. And then I've got a plus 12x, and I'm going to divide that by 4x to give me plus 3. So do you see how this is now written as a product? We have this first part, the 4x, times this piece. So we can write it as a multiplication. Why do we want to write this as a multiplication so badly? There is a lot of reasons. So as we will see coming up, once you can do this, you can solve equations that we couldn't solve before. That's a big thing in mathematics, is solving equations. Also, it's going to allow us in the sections on rational expressions and rational equations to simplify and divide those rational expressions. That's why I'm recommending that you do the factoring sections first before you do the rational expression stuff, because you're going to use factoring in those sections. So you might as well learn the factoring first and then apply them to those other sections, right? But we're good. We've written this as a product, and there's nothing more inside the parentheses that we can pull out. So that's all there is to the greatest common factor. You're just looking for the biggest thing that's in common to all of these, and you divide it out. Later, when you get into the more complicated problems towards the end of the chapter, you'll see more of these where they make you factor out bigger things. A lot of times your problems won't have a greatest common factor in them other than 1. And so so you just end up not doing that step, okay? There's factor by grouping, but I think the videos do a pretty good job explaining the factor by grouping. So what I'm going to do is I'm going to, depending on how time goes, I'm going to skip that because I think people do pretty good just following along the videos on that one. I want to get to where I'm pointing out things that I know confuse students a little bit more when we're doing these problems. And the ones you're going to see more frequently, the most frequent problem you're going to see is a trinomial problem that you have to factor. That's probably 4 times out of 5 what you're going to run across is a trinomial that needs to be factored. Now, the good news is the easy trinomials to factor are like the easiest factoring problems. The bad news is the hard trinomial problems are like the hardest ones to factor. So it just kind of depends on if you get an easy one or a hard one, and then how experienced are you with factoring. Factoring is one of those things where you can watch someone do it, but you really don't get good at it until you've done your own factoring a bunch of times. So practicing the homework and, you know, making sure that you can go through and do that. So let's do an example here. Okay, so we want to factor this polynomial right here. Well, when you do these a bunch of times, you realize you're going to get some parentheses. And the x squareds always break down as x and x. Okay, so we can put those in there. And then what you're going to do now is you're going to look at the signs. You're kind of remembering, you're kind of thinking of it this way. You're thinking of reverse engineering the polynomial multiplication. So it's going to be some form of x plus a times x plus b, or plus or minus, or I guess I should put the plus minus because we don't know if it'll be a plus or a minus in there. But we're looking for something that's in the form of x plus or minus a, x plus or minus b. So, and we have to figure out if it's pluses or minuses, and we have to figure out what those numbers are for the a and the b. But it's going to take this form. So if I look at it, I kind of go, well, this 36 part, that comes from the L part of my FOIL, right? It's the last part of the FOIL. Comes from multiplying the a times the b. So I'm multiplying two numbers together, and I'm getting a positive 36. So what do we know? If I multiply two numbers together and I get a positive number, what do I know? Well, I know that those signs must have been the same, right? And this is where you have to be careful. I hear a lot of students being very sly with their language, and they'll say things like, 2 negatives make a positive. Well, it's true if you multiply. A negative times a negative makes a positive. But I'll see students say things like, well, 2 negatives make a positive, and then they do that when they add things together. Well, if you add 2 negatives together, you don't get a positive, right? So we want to be specific so we don't confuse ourselves. We don't want to say things like 2 negatives make a positive. We want to say 2 negatives multiplied make a positive. Sure. But in this case, that's not conclusive because 2 positives make a positive too if you're multiplying, right? So all I know from this plus 36 is really that my signs up here in my factored form are going to be the same. Okay, that's kind of what we're doing here. We're looking for clues in the polynomial. We have to, you're like a little detective. You're piecing together clues in the original problem and trying to deduce what the factored form must be. So we've just decided that, well, it's either going to be x minus a, x minus b, or it's going to be x plus a, x plus b. But it won't be mixed. It won't be x plus a, x minus b, right? They're either both plus or they're both minus. Well, let's imagine they were both minus. When I go to do the inner part of my FOIL, I would get a negative number right here. So the fact that this is a plus tells us the signs are the same. The fact that this is also a plus tells us it must be x plus something, x plus something. So then we kind of fill that piece in. X plus something, x plus something. Sorry, I misplaced my algebra book that we'll be using shortly here. Right. So then I have to think about the structure of FOIL. When we go through and we multiply these, well, this L part, this 36, comes from multiplying the A times the B, right? Okay, so what numbers can I multiply? What integers can I multiply that would give me 36? Well, there's what? 9 times 4. There's 18 times 2. There's 36 times 1. Let's see, is that all of them? 9 and 4. Nope, there should be 12 and 3. 12 times 3. I think that's all of them now. So we have a list. We've kind of in our brain, or better yet, on a piece of paper, we've written down the possible factors of things we can multiply to get 36. Now, the way that, where does this 13x come from? Well, that's the outer term and the inner term combined. So whatever numbers on the outside and whatever numbers on the inside, those are supposed to get us to 13. So you start thinking about those numbers I just listed to multiply to 36. 9 and 4, 18 and 2, 12 and 3, 36 and 1. Using those numbers, is there any way to get a 13? Let's see. 36 and 1? No. No, can't add those to get a 13 or subtract them. Let's see. What if we had 12 and 3? No, that's not going to work. 18 and 2? No. 9 and 4? Oh, yeah, that works. With a 9 and a 4, we can get a 13, right? So I go through and I put those in here. 9 and 4. And it turns out that that is, in fact, our factored form. How do I know that? Well, it's always a good idea to check your work. So it's really nice. Remember, multiplication of polynomials is easier than factoring. So once you've factored it, the check to see if you did it correctly is to multiply it back out and see if you got what you started with, right? I recommend that because on Delta Math, if you get the problem right, you don't end up having to do extra problems, right? Remember, if you lose that point, you have to do another problem correctly to get it back. So it's better to just check it in general. But also in everyday life, you have to check your work. There's no back of the book to tell if you did it right or not. So let's multiply this out. Let's see. So if I FOIL it, I'm going to get x squared plus 4x plus 9x plus 36. And sure enough, when I simplify that down, I get x squared plus 13x plus 36. So I know I did it right. This factored form is correct, and we're good to go. So then you would move on to the next problem, and you would do the next one. Okay? So we might have a problem like, x squared minus 2x minus 63. Okay, so first thing you do is write your parentheses, and then we know it's going to be x and x. Now let's see, with a negative 63, that means when I multiplied the L part of my FOIL, I got a negative 63. So if I multiply two numbers together and I get a negative, that must mean one of those numbers was a negative number. So that becomes x. That means I have an x plus and an x minus, right? We know that the signs must be different from each other. So then I'm going to think about, okay, how can I multiply numbers to get negative 63 and then add those numbers to get negative 2? Well, 63 doesn't have that many ways to make it up, and 63 and 1 is obviously not the right answer. But let's see, with 63, how about 9 and 7? So if I multiply a 9 times a 7, I can get a 63. And if I subtract those values, I can get a negative 2. So then what we have to do is be careful about putting the right number with the right sign. If they don't match up right, then you've done the problem incorrectly, right? And it will be the wrong answer. Some people go, oh, well, isn't it the same thing? It's not. You can try it. Write out two factors, change the signs, multiply it out, you'll see they don't match. You don't get the same thing. So I have to figure out if the 9 goes with the plus or the 9 goes with the minus. Well, when I do the inner and the outer, I end up with a negative. So that tells me that the bigger number must go with the negative. So I'm going to make this x minus 9, x plus 7. And then if we multiply it out, you get x squared minus 9x plus 7x minus 63. And it all ends up being the correct answer there. Okay, so these are the kind of the simpler of the trinomial problems, and it's okay if you're confused and you're saying, man, he's saying these are simple, but they're you know, I'm still kind of confused by them. That's okay. When I say simple, I'm not saying easy. Some of you might find them to be easier than others, but remember, simple is different than complex. It doesn't mean easy. So these problems are simpler than the ones that some of the other problems you'll be running across in the chapter. Okay. All right. With that said, before I forget, I better take roll. Thanks to everyone who's kind of checked in here. Let's see. have so on the YouTube stream, Yvonne Borja or Yvonne B. It says it also says your name. Sorry, I'm not seeing a name that matches. Is there a name that would match my role for Yvonne? Otherwise, you can you can meet with me after class as well if you. But I don't have a note here about a different name I'm looking for, so let me know how that works. Okay. All right. Thanks everybody. The fact that everyone throws their name up there makes it a lot easier to go through and do that. I know it takes a few minutes, but we have to take pretty good roll in these classes or people stop coming. And then the pass rates go down, which is bad. It's Yvonne Borja. Oh, sorry, Yvonne. Yeah, you were from the wait list. Sorry about that. You're right. My bad. Sorry. Thank you. Gotcha. Okay. Yeah, that's what it was. Okay, great. Let's get back to some math then. So, like I was saying, the factoring takes practice, takes some experience getting at it. Let's see. People want to know if I got them. Yeah, Jocelyn, I got you. You're in there. Yeah, you're good. And Allison, I got you. You're good. Yeah. Yeah, okay, good. Okay. So so hopefully you'll remember how to factor the simpler of the trinomials pretty straightforwardly. It's just like I say, these simpler ones, once someone does like 10 of them, they're like pretty good at it usually for the most part. You might have to do a few more, a few less, but you kind of get the idea of how things are going, right? But then we get the harder trinomials, and the harder trinomials are obviously harder to do. They take quite a bit more figuring. They're not quite as simple. It would seem like there's a tiny little change, but it just makes it way, way more complex, because instead of looking at for one combination that works together, like 9 and 7 in the last problem, you have factors from two different numbers, and you have to pick the right ones, which in combination are going to give you the right number. And that one, it can be tedious, right? It's not the most exciting math work to do. You may try a few that don't work, and you just kind of have to keep your spirits up and going, well, maybe the next one's going to work. And then you get the next one to work, and then you find the right combination. So let's find an example of that. In fact, let's do it over here. Let's go into Delta Math and do it. So we've got, so let's do like one that we just talked about. So factoring trinomials here, x squared minus x minus 6. Okay, so I know it's going to be parentheses. I know there's going to be an x and an x. This negative tells me that my signs are going to be different. So I know it's going to be x plus and x minus. And then, okay, I need factors of 6 that can get me a -1. Well, 3 and 2. If I need a -1, then 3 goes with the negative, and the 2 goes with the plus. And that should do it. Hit yes. And then it's got it worked out for you. Some of you have learned to draw this big X on your page. I don't have a problem with that. It's fine. I don't really understand how that's helpful, because it's the same thing we just worked through, which is you multiply to -6, you add a -1, it's going to give you a 2 and a -3. But for some people, if they draw a big X on the page, makes it easier for them, great, do that. Like, that's perfectly fine, right? I don't usually teach this X because I don't understand why that makes it easier than just doing it the way I did, where you're doing it in a horizontal line. But if one of those ways works better for you, that's the one you should use. Okay, there's no shame in that. It's just, are you getting the problem right? And if so, great. Then it's working for you, okay? So that's how you do that problem. And then, of course, there's the watch the help video where they walk you through how to do it. They're showing you how everything works, right? So don't forget to watch those videos if you, oops. hide video. That's what I meant to do. And then we go back. So now let's look at the ones I'm talking about where a is greater than 1. So basically what the a is, remember when we write a quadratic, the a is the number that's on the x squared, the b is the number that's on the x, and the c is the constant. Okay, so the thing that's different about these problems is that the number in front isn't 1 anymore. That means, remember how easy it was when I would go, okay, so we're going to have parentheses and we know it's going to be an x and an x? Well, we don't know that anymore because it's 3x squared that we're breaking down. Now, we lucked out in this problem in that our lead coefficient is a prime number. That's really, really helpful because there's only one way to break down 3. 3 times 1. It's a prime number. That's the only way you can do it. So when your lead coefficient is a prime number, those problems are going to be a little bit easier than the really, really hard problems. But in this case, I know that it's going to be 3x and x because that's the only way you can break down 3x squared. You can imagine it's harder, though, if we were trying to break down 12x squared because it could be 12x and x. It could be 6x and 2x. It could be 4x and 3x. I don't know which is the right one. But in this case, the only way you can break down 3x squared is 3x and x, since 3 is a prime. So go, okay, that's not bad. Now I look at the rest of these terms and go, that's right. We knew how to look for some clues. This plus tells me the signs are the same. And if they're the same, this one tells me they're both plus. So it's going to be 3x plus something times x plus something. Now, what we did before is we'd say, well, I want things that multiply to 28 and add to 25. We don't get to play that game anymore because the 3 messes up the whole process of multiplying. It sort of makes it more complicated. So this is where what comes into play is what they call guess and check. Some of you may need to do guess and check for the problems we just did a minute ago, those simpler ones. That's okay. Do it for a little bit and you'll get better at those other ones, and then you won't have to do the guess and check as many times. But for these problems, you generally do have to guess and check a little bit. Okay, so let's jump over to here so I can show you some steps. So we've got, it's what, 3x squared. Is it plus 25x plus 28? So was I right? Is that what it is? 3x squared plus 25x plus 28. Yeah. Okay. And we said that okay, so we knew it was going to be 3x plus and x plus. So this is as far as we got on the other page. So that I was able to do that just by kind of looking at things. But when it comes down to crunching numbers, again, don't try to do the stuff in your head. I'm not trying to do it in my head. You shouldn't be trying to do it in your head either. So I have to think about what are the ways that I can break 28 down and put them in here. And then in combination, when I'm multiplying these, I'll get 25. See how that's a little different than just saying what multiplies to 28 and adds to 25? This 3 makes it complicated. So I got to see how things are going to fit in here and try it out. So let's see, 28. Let's see. How are you going to do that? 14 and 2, 7 and 4. I think that's about it. So let's try 7 and 4. And then depending on how good you are at this, how many problems you've done in the past, and you start to kind of piece it together, you'll start to kind of see where you should put certain numbers. Doesn't mean you're doing the problem in your head, but you're kind of like, well, if I put it here, I think it's going to be too small. So then you put it the other way and see where it works. So if I'm thinking about 7 and 4, I think I want that 7 to multiply the 3. So I'm going to put it on the outside so that the 7 will multiply the 3 when I do the outer. That means that this one in here becomes a 4. Now, did I do that right? I think I did, but I don't really know. So what should I do? I should check it by multiplying it out. So let's see. If I multiply this, I'm going to get 3x squared plus 21x, because it's 7 times 3. 3x times 7. Plus 4x plus 28. Yeah, it looks like that worked because when we add the middle ones, we get 25x. Okay, so that worked. If it turns out you put the 7 and the 4 in the wrong place and it didn't work, just cross it out and then try it the other way. You're just going to try combinations till you get them right. And the more of these problems you do, the sooner you will get the right answer, because you'll sort of start to get the sense of when one of them seems like it's not going to be right, and you skip that one, and you're more likely to get the right one. This question always comes up. Is this the same answer? When I did it, I got this other thing. See how it's the same answer as this up here, but just the factors written in a different order? That's the exact same thing. That would be like up here if we said, well, 22 is 2 times 11, but is 22 also 11 times 2? Yeah, it doesn't matter what order you multiply things in. Multiplication's commutative. You're going to get the same thing. So it's the same thing down here. If your factors match exactly, but they're in a different order, they're still okay. What is not still okay is some people will go, they'll take this. Maybe we've got x minus 5, x plus 4, and then they'll go, and then they'll write it as x minus 4, x plus 5. And they'll go, well, isn't that the same thing? It's the same numbers. I see the same numbers and x's in here. And you go, right, but in this one we have a negative 5, and in this one it's a positive 5. In this one it's a negative 4. In this one it's a positive 4. In that case, it is not the same. These two here, if you multiply these out, watch, let's multiply it out. If we multiply this out, we're going to get x squared minus x minus 20. And if we multiply this one out, we're going to get x squared plus x minus 20. Okay, see how you get a different thing? So you got to make sure that the factors match identically. Otherwise, you're going to get something different. And sometimes there's a tendency to go, well, aren't these kind of the same? They're only different by a sign. Well, sign's a big difference, right? If you go to the bank and you think you're supposed to have $1,000 in your account and they screw up and they have you at negative $1,000, are they going to be like, oh, it's just a little thing. It's just a negative. No big deal, right? It's a big deal between someone owing you $1,000 and you owing them $1,000, right? That's a big difference. So negatives are a big deal. Plus, if you start plugging values in for x, these expressions will give you totally different values almost all of the time. So just think about that when you're making these judgments about whether they're the same or not. These are different. These ones up here are the same. So just make sure they match exactly. And it's just going to be a matter of you going through and practicing these until you get good at them. So let's see, what was our answer up here? We didn't finish that problem. It was 3x plus 4 times x plus 7. So 3x plus 4 times x plus 7. And we submit. And there we go. See how they don't have the x on here anymore? Because it doesn't fit when your lead coefficient is not a 1. The x doesn't make sense anymore. That's not how we do that problem. Okay. You just kind of have to get the right combination. Oh, they even have it where you can pull it down and you can try the different factors, and you can look at that. You can see how the other ones don't turn out right because you get the wrong middle number. Oh, that's pretty clever how they do that. I think that's new. I don't remember that being there in past semesters. Anyways, it's kind of interactive solution there. You can play around with a little bit. It's helpful. And of course, watch the help video, and they'll walk you through how to do that as well. Help you out with that. Okay, let's try this one, level 2. What was different about level 2? This one seems easier. I don't know why this one's level 2. This is actually a really easy problem because the 3 in front is a prime, so we know that's going to break down as 3x and x. And the 1, how many different ways can you break down 1? 1. So this one's actually pretty straightforward. It's going to be 3x plus 1 and x plus 1. Hopefully I don't get it wrong there. Yeah. And then you do it. So sometimes they're not too bad. Why was that one they thought was hard? Yeah, these ones aren't too bad either because in this case the first and last digits are prime. So there's not that, there's not that many combinations. This one's going to be 5x and x. This one's going to be 5 and 1. And then you're going to play around with the signs a little bit. But that's not too bad. Let's see. Let's go here. All right, this one, okay, this is where they start to get to be kind of a pain. Why is that? Well, we no longer have a prime number out in front, which means I don't know if this breaks down as 6x and x or 2x and 3x. Okay, that's kind of a bummer. And then over here with 35, well, let's see. The only way to break down 35 other than 35 and 1 is 7 times 5. So the good news is we don't have too many choices. The real pain of these problems comes in when there's lots of factors. Like if your lead coefficient is a 12 and you've got, well, it could be 4 and 3, could be 6 and 2, and then maybe your constant has a bunch of factors like 24, which could be 6 and 4, 12 and 2, all sorts of different things. Then you have lots of combinations that you have to check till you get the right one. In this case, let's see, 2x. So 6x, I'm guessing, is going to be 2x and 3x. And it looks like they're both going to be pluses from reading the signs in the polynomial. And I have to figure out where the 7 goes and where the 5 goes. So I think I think it might be 6 and 1 maybe, actually. Let's see. If we go 6x and x, and then I put the 7 here and the 5 here. It's just a matter of finding those right combinations. So you kind of go with your gut feeling while you're filling them in, and then you multiply it all out and see if it works. Right? Don't do what I'm doing here. Like I do hundreds of these all the time, like because I teach it all the time. So I kind of have a pretty heightened sense of what's going to work and what doesn't. But when you're just learning this, you should be multiplying it out on a piece of paper to make sure it works right, so you don't lose that score up here. You don't lose that penalty for getting one wrong. So in this case, I've got what, 6x squared plus 42x plus 5x. Yeah, so that one's right. But you can see as they break it out, these ones are harder to find the correct combination. You have to find a combination that works. And they're kind of a pain. I think we talked about difference of squares last time. So remember, you've got your difference of squares formula. Most people remember it right away, but in case you don't, that's okay. You just have to sort of play with it. So a squared minus b squared equals a plus b times a minus b. And people are good at these. You're basically just taking, you're taking the square root of the first term, square root of the second term, and you're just plugging them into this format of the sum times the difference. So for instance, if we have 36x squared minus 49y squared, then I would say, okay, what are the square roots of these terms right here? Well, 6x and 7y. So you're going to plug in 6x and 7y according to this form right here. So 6x plus 7y, and then 6x minus 7y. And that's it. You can multiply it back out. The reason this works so well is the inner terms. Remember in the FOIL, the inner and the outer terms, they cancel each other out. That's why you get these squaring terms right here. So back to this problem, this one should be 5 plus x and 5 minus x, right? So the square root of 25 is 5. The square root of x squared is x. So I just put it in that pattern of summing and the difference to get this And there we go. See how they take the square root? You put them in this pattern, you're good to go. Let's find another one. Is that the same problem? I think it just gave us the same problem again. 5 minus x, 5 plus x. Yeah, I got it right again. Look at me, I can really do that one problem. It's just, this is weird. It's giving us, it should be, sometimes with random numbers, you get the same number a few times in a row, but that's kind of weird. I know this one's in a different order, but it's weird we keep getting 25. Okay, so now it's going to be 2 minus x times 2 plus x, right? You see how these ones are working. Let's look at the level 2. This is kind of like the one we just did. Remember, what's the square root of y to the 4th? It's y squared. So this one should be, well, the square root of the first one's going to be 5x squared. You can, if you hit the keyboard button, remember, it'll give you the, let me move this up so you can see. If you hit the keyboard button, it gives you this like calculator screen, and then you can use these buttons right here for your exponent. So if I've just got my x and I hit this, it puts a squared on it. It's going to be 5x squared plus y squared. The other thing you can do is you can use the caret button. It's shift 6. So see the symbol above the 6 on your keyboard? That's called a caret. And that's pretty universally exponents in software. So you can press that, and then you don't have to grab the mouse and go click things. And then it's going to be 5x squared minus y squared. And I got it. So it's the same idea as the other ones we were doing. So difference of squares, pretty straightforward. I've got the difference of cubes in here. I kind of have my doubts as to if that's going to come up in second semester. So probably, like, you know, I doubt, like, I have to cover it because we're talking about we're talking about factoring, which includes cubes. But I would say don't worry too much about these. Like, if you're really struggling with these, like, try to get them. But if you're really struggling, I don't think they're going to play a very important role in what we're doing in the course. Okay, like the cubes ones. The squares probably will come up. Books like to put those in there, but most students do pretty well with them, so you don't really have to worry about it too much. Okay, let's see where we at. We did trinomials, grouping. Oh, solving quadratics by factoring, right. Let's look at some of those. So solving quadratics by factoring. Okay, good. We have kind of just enough time to talk about it. So x squared minus 9x minus 15, x squared minus 9x minus 15 equals negative 5. X squared minus 9x minus 15 equals negative 5. Okay, so how do you do these problems? Okay, step 1, you need to get 0 on one side of the equation. Well, which side do I want to get, oops, I'm not showing the right one. Which side do I want to get 0 on? Well, you're probably going to work to get 0 on the right side because you want your x squared term to be positive. It just makes the whole thing a lot easier. So I'm going to add 5 to both sides. And that's going to give me x squared minus 9x. So adding 5 to both sides gives me negative 10. Negative 15 plus 5 gives you negative 10, right? I know some people get rusty with adding and subtracting negatives. I find a lot of students can keep track of it if they think about it as a bank account. If your bank account says you're at negative $15 and you add $5 to your account, then what do you expect it to be at? Negative 10, right? Some people go, yeah, but 15 plus 5 is 20, right? But it's a negative 15 and a positive 5. So if you owe someone $15 and you give them 5, you now only owe them 10. So you're at negative 10. So now we have the 0 on the right side of the equation, which is what we want. But what we're going to do doesn't work unless you have 0 on one side of the equation. Now what you're going to do is you're going to factor the left side, right? We did all this work with factoring. Now we need it in order to solve equations. So now I'm going to factor this and keep writing it as an equation. There's a tendency for students when they have an equation and they factor part of it to all of a sudden the equal sign disappears, and then at that point everything kind of unravels. So make sure you keep writing equations. So this would be, let's see. All right, let's see. We're going to have an x plus and an x minus, right? Because when I multiply the L part of my FOIL, I get a negative 10, so it's going to be a plus and a minus. We've just got the x squared here. Wait a minute. Did I do this right? Oh, 10 and 1, of course. That took me way too long to figure out. So it's going to be x minus 10, x plus 1. Right, so that's my factoring. If it's taken you a little longer to do the factoring, that's okay. I've been doing this a long time and you're kind of new at it. So cut yourself a break. But this is the correct factoring. If I multiply this out, I get it. So now, remember, factoring is all about writing things as a product. I want this thing times this thing. Why is that? Well, there's a few reasons, but one of them in this case that is really important and is pivotal for this problem is that in the real numbers, if you multiply two real numbers together and you get 0, and that's what we have a thing multiplying a second thing and getting 0, that means one of the things you multiplied together had to be 0. So if you take that to its logical conclusion, that means that either x plus 1 equals 0 or x minus 10 equals 0. Okay, so what did I do? I set the factors that were up here equal to 0. And now we're going to go through and solve those. But these are easy. We have two equations, but they're easy equations. Way easier than the one equation we started with. So we took one hard equation and we broke it down into two easy equations, which then is going to give me x equals negative 1 or x equals 10. Okay, those are my two answers. When you solve a quadratic, remember a quadratic is a second degree polynomial, which this is, you should get two answers. We got negative 1 and 10. So what do? Again, you always want to check your work before you plug it into the computer so you don't have to end up doing extra problems. But let's see. Let's take negative 1 and plug it into the original problem and see if it's a true statement. So I'm going to get negative 1 squared minus 9 times negative 1 minus 15 equals negative 5. Let's see, is that true? So that would be 1 plus 9, which is 10, minus 15 equals negative 5. Yeah, so negative 1 is definitely a solution. What about 10? Let's try 10. So 10 squared minus 9 times 10 minus 15 equals negative 5. So 10 squared minus 90. So 100 minus 90 is 10, minus 15 is negative 5. Yeah, that one checks out. So both of these answers are correct. It's really easy to get an incorrect answer. It's just a little mistake with a sign, or I see this and I know students know the right answer, but it's easy to make a mistake. I see students do this where they'll have they'll write 4 plus 5 and then they write down 20. And it's like, I know what you're thinking. You were thinking multiplication, right? Because you're focusing on the different part of the problem, and you said 4 plus 5 is 20, which, of course, 4 plus 5 is not 20, but it's easy to do in this kind of work. You make that mistake. So it's important that you check those problems at the end and make sure that you're doing them correctly. Just plug them into the beginning, and then you don't end up risking having to do the problem over again, right? Because you missed that point. So let's see, what did we get? -1 to 10. -1. I believe when you have multiple answers, we're supposed to use a comma. Yeah. So -1 or 10. So you can do that either by typing the comma in here, or you can use the plus or minus buttons to give you more or less spots for answers that you're going to answer with. So -1 and 10. Hit submit. And they do the same thing. So it looks just like mine. They got 0 on one side. They factored it. They set the factors equal to 0. And they solved each one. And we get our solution. It's pretty much how it's going to work for all of these problems. Now, what we want to remember, this is kind of important, not every polynomial is factorable, which means you could run across quadratic equations that can't be solved by factoring. Well, then what are you supposed to do? Well, that's where the quadratic formula comes into play, and we're not learning that yet. That's a little, probably a few weeks, maybe March sometime we'll be learning about that. Okay, but other than that, these pretty much work the same always, and they say solve for values of x by factoring, right? And of course, you've got a nice little video here to help you do it, explain how it works for that stuff. Let's see, anything we need to do by next time? Yeah, so work on your factoring. Tons of videos on factoring. You've got the ones that are built directly into the Delta Math. You've got the ones that I've posted on Canvas. And YouTube is full of videos on factoring. So if you have a particular YouTuber that you like to watch lessons from, go watch it from them, right? But that's fine too. However it is that's going to make sense to you. So do that. Next time we will talk about the rational expressions. So intro to rational expressions I'll talk about next time. And the rational equations we'll talk about next time. I covered those real briefly in that one. Actually, in here we didn't meet that week, so never mind. But yeah, so I'll go over those next time. So even though they're in a different order on here where the rational equations and rational expressions come before the factoring, do the factoring first. They all have the same due date, right? February 14th. But do the factoring first, and then the rational expressions and equations will be a little bit easier for you. Will there be a midterm? So it just depends what you call a midterm. The term midterm is usually just like a test that happens in the middle of the semester. And so the answer is yes. There will be there's a test roughly in the middle of the semester, and then there's a test at the end, which is your final exam. So so yeah, basically when we complete the algebra portion of the course, there'll be a test on it. And then we'll start the math for meds with the second set of homework in the second book and everything. And then there'll be a test at the end of that section. So 2 major tests, one after the major parts of the course, and so on. There's a question in here about grades. So the question is the grades going to stay locked? I assume you mean like where it's invisible. So there's a couple of reasons why I don't like have the grades posted, because a lot of times, especially the last couple semesters, what happens is students start making assumptions about how grades are calculated, and then they'll think they have a grade that they don't have. And you might go, well, doesn't it just tell me the grade in the grade book? The problem with grade books is there's generally 2 settings. One is that it won't hold against you assignments you haven't done. So if there's an assignment that you haven't done, it won't give you a 0 on that assignment, right? So the problem with that then is what some students will do is they do the first homework assignment and they get 100% on the homework, and then they don't try any other homeworks, and it will say you have 100% on your homework. But they don't really, because they have like 10 assignments that they didn't do. So then the other option is to have it set so that it awards 0s for any problems that haven't been completed yet. The problem with that is that means that your grade is artificially low, because it's counting all the assignments we haven't done yet as 0s. That's generally built into the grade system. So what happens is if I have it set one way in the grade book, students think their grade is higher than it really is. And if I have it set the other way, students think their grade is lower than it really is. So it's I don't usually have the gradebook visible because students just confuse themselves. And then, you know, like I've had students that think they have a B when they really have a D because they're not reading it correctly. But in this class, let me remember, I think the grade's pretty easy to calculate. Oops. Oh, is it going to lock me out? Oh, it let me in. So if we go to the syllabus. Yeah, it's 50% homework, 50% exams. So basically, just take your homework score, whatever your grade you're getting on the homework, and for most of you that should be in the 90s or 100. And you're just going to average that with your exam scores, your exam average, and that gives you basically your score in the class. So that way you don't have to worry about the thing doing it incorrectly. Yeah, so there's a question here about, is the new license available for the Math for Meds portion at the bookstore yet? Not yet. It will be. I worked out this. I had a meeting with the rep this morning, and we got everything squared away. I was like 99% there, but there was a glitch on their end, which was making the class not show up for my Tuesday class. So I was having an issue with it. So I should be good to go ahead, and I will talk to you next week about buying. You can just buy the license. You don't even have to go through the bookstore. You can just buy it directly through the online homework. You don't even have to mess with the bookstore through there. So yeah, it should be next week. You should be able to buy it directly through there, and then we won't even start that stuff for another month, but I will have it populated. Looks like it's more or less ready to go. I just got to throw some assignments in there and then get you the code so you can sign up with it. But you don't have to move ahead with that yet. So a good question though. Okay, so with that, I'm going to shut down the YouTube stream. I will stick around in Zoom, so anyone who wants to talk to me or ask me questions, you know, we only meet once a week, which is a long way off, so I know it's hard. So feel free. Please don't be intimidated or nervous or scared. I'd much rather have you stick around and ask me a question that will help you get more done in the next week than have you be intimidated to, you know, talk to the professor or whatever. So if you're good and you're comfortable, go off and start working on the next round of homework. If you want to talk to me and you have questions, please come into Zoom and I'll discuss, you know, whatever you need to. Okay, thanks everybody.